Hello friends, today we are going to start new subject thermodynamics. See student, this is one of the most fundamental subjects of mechanical engineering and it forms the basis of entire thermal science. Now see, it is worth 4 to 6 marks in gate examination. And the books you must refer are first one P.K. Nag and the second one I would recommend to my students is that of Eunice A. Sengel. These are the two books you must refer while preparing thermodynamics. Fine. Now see, in introduction to thermodynamics, there are some basic definitions. The first definition is that of system. Now consider a room. Let this be a room and we have attached a heater to it and heater is giving heat Q to the room and we are interested to find the change in temperature, of the air in this room. Fine. So this room, the air in this room becomes our system. So system can be defined as region in space or quantity of matter chosen for thermodynamic analysis. So system can be defined as region in space or quantity of matter that is chosen for our thermodynamic analysis, where we are interested to find thermodynamic properties or change in thermodynamic properties. Fine. Now see, system is classified into three broad categories. First is closed system. Now see, let us understand closed system with some examples. The first example is that of water heater. See, this is a closed vessel and it contains water and we give heat to it. What happens to the water? Its temperature rises. So here what is happening? We are transferring heat to the system and this is our system. But see, there is no mass transfer into the system or out of the system. So we say that closed system, it allows energy transfer between system and its surroundings, and it does not allow mass transfer. Fine. See, the second example of a closed system is that of piston cylinder arrangement. Now see, this is our piston cylinder arrangement. This is our piston. And here is the gases and we are interested in this portion. So this region becomes our system. Now we give heat to this region, what will happen? The piston will move this way, or the gases in this chamber in our system will expand. So what will happen? The final position of the piston is somewhere here, and here again we see that heat is getting transferred to the system, but there is no transfer of mass into the system or out of the system, and such a system is known as closed system. And see, this system is also known as control mass. Why it is known as control mass? Because here the mass remains constant. See, there is no mass transfer, so here the mass remains constant. That's why a closed system is also known as control mass. Fine. Now see, the first one was closed system and the second one is open system. Now see, open system allows both mass as well as energy transfer. See, let us understand open system with some examples. The first example is that of boiler. Now see what is happening. Here water is coming in this container and we are giving heat to the water. We are giving heat to the water, due to which water gets converted into vapor and water gets exit from the top of the container. So we see that here mass is getting transferred. See, this becomes our system. This region becomes our system. Here mass is getting entered into the system and here the mass is getting exit from the system, and from here heat is getting transferred to the system. So such a system is known as open system, that allows both mass as well as energy transfer. Fine. Now see the second example. Now see, this is a case of a turbine. See, some fluid is getting entered in the turbine and it rotates the shaft and doing some work, and the fluid gets exit after doing the work from the turbine. So this becomes our system. So we can see that mass is getting entered, mass is getting exit, and there is a transfer of energy in the form of work. So such a system is known as open system because it allows both mass transfer as well as energy transfer. And open system is generally known as control volume. Why it is known as control volume? Because in open system generally the volume is fixed. See, closed system was known as control mass because there was mass was constant, and here the open system is generally referred as control volume because here generally the volume remains constant. Fine. Now third kind of system is that of isolated system. Now see, isolated system means, that means we are isolating our system from its surroundings. So there is no mass transfer, neither there is energy transfer. So such a system is known as isolated system, which does not permit mass as well as energy transfer across the boundary of system. Now see, example, closed, comma, rigid and perfectly insulated container. See, this is a closed container and its boundaries are rigid. That means its boundaries are fixed and we provide perfect insulation all across the boundary of system. So by doing this closed system, what we are doing, mass transfer is equals to 0. See, the system is closed, so the mass cannot leave the system or the mass cannot enter the system. Now see, rigid means the walls of the container are fixed, and here for obtaining work we know that there must be a expansion process, so the walls of the system should be flexible, but here the walls of the container is rigid, so we say that work transfer is equals to 0, and by doing insulation we can say that heat transfer is equal to 0. So a closed, rigid and perfectly insulated container, there is no mass transfer, there is no work transfer, nor there is any heat transfer. So we say that there is no mass transfer and no energy transfer in isolated system. Fine. Now second definition, surrounding. See, anything external to the system. See, this is our system. We are interested only in this region. And anything external to the system is known as surrounding. So surrounding is simply known as anything external to the system is known as surrounding. Now see, now suppose system loses 5 kilojoule of heat. Suppose system loses 5 kilojoule of heat and that 5 kilojoule of heat will be transferred to its surrounding. So we can say that surroundings compensate for the activities of system. Surroundings compensate for activities of system. Fine. This is surrounding. Now come to third definition, boundary. Now see, the surface that separates system from its surrounding is known as boundary. Now see, here the walls of this container separate system from surrounding, and the walls of the container are known as boundary of system. See, the walls of the container are the surfaces that separate system from its surrounding, and the surface that separates system from the surrounding is known as boundary. So it can be defined as surfaces that separate system and surroundings. Fine. Now see, boundary. Boundary can be real or imaginary. Similarly, boundary can be fixed or flexible. Now let us understand various types of boundaries with example. Suppose this is a balloon and we are inflating it. What will happen? It will get inflated and its size will grow. So here we see that the boundary of the system is flexible. So here we see that the boundary of the system is flexible. Fine. Now consider another example. Piston cylinder arrangement, and we are giving heat to our system. This is our system. Fine. Now when we give heat to this system, the piston will move in this direction. The piston will move in this direction. So let this be surface 1, surface 2, surface 3 and surface 4. Now we see that 1, surface 2 and surface 3 are rigid or fixed. That means they are not moving, whereas see, the surface 4 is moving, so it is known as flexible. So piston cylinder arrangement is a combination of fixed as well as flexible boundary. Now see, now consider the room in which you are sitting, and suppose there is 1 meter cube of air. Now our system is only 1 meter cube of air. Can we see the boundaries of the air? No. See, so here we have to plot imaginary boundaries. Fine. So imaginary boundaries are possible. Now Now see, this is a nozzle. From this side our fluid is entering and high fluid velocity is getting exit from this cross section. Now this dotted line represents our system and it has got four surfaces: surface 1, surface 2, surface 3 and surface 4. Now see, surface 1 and surface 2 are that of surfaces of nozzle, so they exist practically in this nature. So surface 1, 2 are real in nature. Whereas see this inlet and outlet, surface 3 and surface 4 are imaginary in nature. See. So nozzle is a perfect example that has a combination of real boundaries as well as imaginary boundaries. So we see that all the permutation and combinations of real, imaginary boundary, fixed and flexible boundary are possible. Now come to the fourth definition, universe. Now see, this is our system and external to the system is our surrounding, and between system and surrounding there is interaction of mass, there is interaction of heat, and there is interaction of work. Fine. See, if we together take this surrounding as our system, now see, earlier this was our system. Now we have taken system plus surrounding as our system. So what is happening? There is mass transfer, heat transfer and work transfer within the system, but not across the boundaries of system. And this system plus surrounding is referred as universe. And since there is no mass transfer or heat transfer or work transfer across the boundaries of universe, so universe can be considered as isolated system. Now students, see, there are two approaches of studying thermodynamics.